I'm going to go through a few problems for our Unit 6 review, and if you guys have any additional questions, please let me know. And remember that you can pause this video at any time if you need. I'll go pretty fast through these just so I can get through as many as possible. So remember that you can pause. All right, so on this one, we've got Tyrell wants to use the Fermi process to estimate the number of blueberries that would fit in an empty city bus. As part of the process, he needs to estimate the volume of a typical city bus. He figures that a city bus is about 40 feet long, 10 feet wide, and 10 feet tall. So what would be the approximate volume of the bus? All right, so the bus is like a rectangular prism. So remember that volume will give us length times width times height. So we'll go 40 times 10 times 10. So the approximate volume of a bus is 4,000, there we go, feet cubed. In scientific notation, this would be 4 times 10 to the third feet cubed, because we got those 3 zeros there. So make sure you guys know how to find volume of different shapes. Make sure you know how to turn things into scientific notation as well. We have population density. Remember that for population density, it'll be people divided by the area. So for this one, it'll be 578,992 people divided by 67.2 miles squared. Once I do that, I get 8,615.95, and then my decimals keep going. I'm going to round up to the nearest person, so I'll get 8,616 people per square mile. So remember, with population density, it's people divided by area. All right, now we've got another density problem, but this is dealing with mass and volume. So remember that your formula for density is mass divided by volume in this case. All right, so we've got a block of southern pine wood, has a mass of 54.6 grams and a density of 0.65 grams per centimeters cubed. The block is a rectangular prism with a length of 4 centimeters and a width of 3 centimeters. What is the height of the block of southern pine? All right, so we want to solve for volume. So I can actually manipulate my density equation to be the volume is the mass divided by the density. I'd make sure you have both of those in your notes. So our volume will equal our mass, so 54.6, and then divided by 0.65. So our volume is 84. Once I divide that, remember that volume is length times width times height of a rectangular prism. Well, we know our length right here. We know our width as well. We know our volume. Our volume is 84, so 84 equals 4 times 3 times h, which is our height. So we got 84 equals 12h. Divide both sides by 12, and that gives us that our height is 7 centimeters. So this is an example of geometric modeling. We've got a bedroom wall that is shaped like a trapezoid. So I'm just going to draw that. And it says that our height is 8, one base is 10, bottom base is 13. And then we've got a circular window, and the radius is 2. So what we need to do is we need to find the area of the trapezoid and the area of the window. So first up, area of a trapezoid is 1/2 times the height times base 1 plus base 2. So if we plug in our numbers here, we got 1/2 times 8 times 10 plus 13. And that gives us, once we plug all that in, an area of 92. Next up, we need to find the area of a square, which is pi r squared. So that will be pi times 2 squared. Once we do that, our area is 2.5, oh, that's a 5, 56. All right, and because it says without the window, that means that we need to subtract our areas. So 92 minus 12.56 gives us an area of 79.44 feet squared for this one. All right, for font sizes, make sure that you pay attention to where it says if it's a scale factor or if you're trying to find like the next smallest or the next biggest size. So for this one, we know that our scale factor is 1.42 and one of the scale sizes is 2.863. So the next smaller scale size would mean that we would go 2.863 divided by our scale factor of 1.42. And we'll go to 3 decimal places, so the thousandths. Once we divide that, then we'll get 2.016. If we wanted to go to the next bigger, so this is the smaller, if we wanted to go to the next larger scale size, we would do 2.863 times 1.42. And if we do that, let me plug that into my calculator really quick. Our next larger scale size would be 4.066. So if you want to go smaller, if you know the scale factor, then divide. If you want to go larger, then multiply. All right, with this one, we've got a box without a top that's made from a rectangular piece of cardboard with dimensions 4 meters by 2 meters. So I'm going to start drawing this here. So we've got 4 meters by 2 meters by cutting out square corners with side length x. So this will look like this on our picture, and the lengths are x. So I'm just going to label each side of this as x. And we want to know what expression can be used to determine the greatest possible volume of the cardboard box. So remember, volume is length times width times height. So because we know that volume is length times width times height, we know our length and our width. So that will be 4 minus 2x, because we have to account for the sides that are being cut out, so like that x and that x. And then we'll have 2 minus 2x, and then we'll have x because we don't know what our height is. So that will be the expression. And then if you need to find the greatest possible volume or the greatest possible value of x, you need to plug this into a graphing calculator. So to find the greatest possible value of x, you're going to look at the x coordinate of your max. If you want to find the greatest possible volume, then you need to look at the y coordinate of the max. Geometry on Earth problems, make sure you pay attention to what shape you are going to be using. So here is a cylinder. Okay, so with this, we're going to need volume of a cylinder. So we know that volume is pi r squared. Oh, excuse me, bless me. Sorry about that, guys. Times our height. Okay, notice that we've got our height already, but it says that it measures 87.92 centimeters around. So that's our circumference. So remember that circumference is 2 pi times r. So we can actually find what our radius is, because we're going to need what our radius is for our volume. So our circumference is at 87.92, and then that equals 2 times 3.14. Notice it says use 3.14 for pi times r. So after doing all that math, I find that r equals 14. Okay, so with this, I can plug stuff in here now. So I've got 3.14 times 14 squared times 160. So I know that the volume of my water tank is 98,470.4 centimeters cubed. So make sure you guys know how to find the radius from the circumference on this one. All right, with the horizon ones, like this one, it's easiest to draw a picture so then you guys can visualize what's going on with it. So we've got a person standing at the top of Mount Everest, would be approximately 5.5 miles high. The radius of Earth is 3,959 miles. So what is the distance to the horizon from this point? And then notice it says round only your final answer to the nearest tenth. So I'm just going to draw a circle here. Obviously it's not going to be a good circle because, oh man, you guys know my drawing skills. And then I'm going to draw a right triangle. Alright, so my right triangle is going to represent how I can find my horizon. So I know that my radius is 3959. So 3959 here as well. And then this little section right here is going to be 5.5. So for this, we're going to use Pythagorean theorem to find our missing side right here. So we're going to go a squared plus b squared equals c squared. We'll have 3,959 squared plus, I'm going to say our b squared is our missing side. And then our hypotenuse will be this entire side right here. So it will be that 3959 plus 5.5 squared. Okay, so then doing some math here, so 3,959 squared gives me a really big number. So 156,73601. Oh, 81. There we go. Plus b squared. And then all of that on my right hand side will give me 15717,260.25. Alright, now I can subtract what's on my left hand side to get b squared by itself. So when I do that, do my calculator really quick. So when I do that, I get 43,579.25. Then I'm going to take the square root. So remember, whenever you want to get rid of a square, you want a square root. So then I get that the horizon is 208.8 miles away. So with horizon problems, make sure you guys use Pythagorean theorem. All right, for 3D objects, so 2D objects rotated around an axis. To get 3D objects, make sure you guys have your notes available from what we took in our Class Connect. So in this case, we have a rectangle being rotated around an axis. Notice that it's touching it. So it's going to make a solid cylinder. If it wasn't touching the axis, it would be a hollow cylinder. For this one, we've got a right triangle being rotated around, so it will make a cone. And then for this one, we've got a sphere being rotated, a circle, a semicircle, wow guys, sorry, a semicircle being rotated around, which means that it will make a sphere. Just got ahead of myself there. Okay, and then next up is cross sections. So make sure you guys have our notes on cross sections as well. So if a rectangular pyramid is sliced so the cross section is parallel to its base, the shape of the cross section will be a rectangle. Remember, if it's parallel to the base, it's going to be whatever the base shape is. Okay, for this one, a cone is sliced so that the cross section is parallel to its base. Remember that the base of a cone is a circle, so that means that it will become a circle. All right, and then our last one that I wanted to go over was areas of those cross sections. So on this one, what is the area of a cross section that is parallel to face ABCD? So notice that face ABCD, I'm going to highlight it here. So if it's parallel, remember it's going to be that same shape. So notice that ABCD, our dimensions are 6 by 12, which means that a parallel cross section would also be 6 by 12, which would give us 72 centimeters squared. All right, if you guys have any further questions, please let me know. We are here to help you, and good luck on your test.